joining our webinar, Creating a Winning IoT Strategy for Manufacturers, Logistics, and Service Providers. I'm Grackin, CEO of ChainLink Research, and I will be your moderator for today's webinar. But before we begin the webinar, I want to go over a few housekeeping issues. This webinar is being recorded, and you will receive a recording after the session. Now, of course, you want to know how to ask questions. So many of you will note a control box on the right-hand side of your screen. For some of you, this will already be shrunk. And so if you want to enlarge it, you can expand it by clicking on the arrows you see, and the Q&A box will reappear again. Now, you may also want to move or shrink this. So in order to move it, you click on the little dots in the bar, and you'll be able to drag the box where you need it or off the screen. You'll also be able to shrink it by clicking on the double arrows on the right. Now, if you want to ask questions, you can open the question box. For some of you, the box may not be open. You'll see the plus sign, and you need to click on that. Once it's open, you just type in your question and hit the submit. You can ask multiple questions during the session, but we will not be answering them till the end of the presentations. However, feel free during the webinar to ask your questions. So now let's get started. We have two great speakers today to cover this most important topic. Our honored guest speaker today is Howard Heppelmann. Howard is Divisional Vice President and General Manager of Connected Product Management Segment at PTC. Howard is the leader and he is the General Manager in this group, and he is responsible for business strategy of PTC's Connected Product Management Segment, in other words, IoT. Howard brings vast domain experience, having worked in manufacturing and PLM for most of his career. Thus, he brings a deep perspective about products from design through service. Bill McBeath, our Chief Research Officer, has been involved in research and strategy with many companies on their IoT endeavors and leads ChainLink Research IoT Research. Bill will kick off the session today and first define IoT and its impact then on logistics and manufacturing. Then Howard will dive into IoT in manufacturing and across the value chain and take us from the grand vision into the practical adoption of IoT and show how users can get started. Our Q&A will follow that. Bill?
Thanks, Ann. It's great to be here. And as Ann mentioned, we'll just start out and make sure we're on the same page about what do we mean by Internet of Things. Our definition, Internet of Things, is intelligent connected objects and the capabilities and services that they enable. So intelligence just means that these objects have sensors and a processor and usually some sort of software embedded in them or surrounded up in the cloud. And they're connected to the Internet either directly or indirectly through a gateway or through some RFID reader or some other means. Now, objects, people usually think of products, manufacturing products, which these can be, but they can also be vehicles, buildings, cities, or even the environment, like putting smart sensors in the soil in a smart farm to tell you exactly how much water to put where. Finally, it's not just about the objects and this intelligence. It's really about what is these sensors and intelligence enable? What are these new capabilities, and what are the new types of services that we couldn't envision before? And that's where we're going to spend most of the time, at least in my section, talking about. So let's dive right in, and we'll talk first about how the Internet of Things actually impacts the manufactured product itself. In this case, I'm showing a car, but it could be anything. It could be a refrigerator or a pair of shoes or a stereo system or an air conditioner or a chair. You get the idea, any product, but for this example, we'll use a car as an example. And we've already seen intelligence and sensors built into cars for a long time with the diagnostics and the engine diagnostics, for example. But more recently, we see more sensors and more important connectivity, so that the car is getting connected to the internet, and now it's entering the era of the Internet of Things, and providing the ability for things like remote diagnostics or predictive diagnostics that could actually tell the owner and the repair shop, hey, I'm going to need some repair, and make it, we could envision an app where at the click of a button you could schedule that repair. And we're already seeing versions of this, things like Verizon Vehicle that plugs into the OBD2 port, which is the diagnostic port of your engine, and you put a Bluetooth speaker clipped onto the visor, and so there you can actually get OnStar-like capabilities, including remote diagnostic, into existing vehicles. And I think that's it's part of a really interesting trend to retrofit Internet of Things into existing products that becomes especially important for long-life products like ships or airplanes or buildings. There's, of course, we've all heard of the roadside assistance like the OnStar I mentioned, or Mercedes-Benz Embrace, Toyota's got their Safe Connect, and there are others as well. And this allows taking some of those sensors and being able to sense things like the automobile has had an accident, we should send some emergency repair. Or even if it doesn't, where is it? I need some roadside assistance. And we have seen other things that can monitor the driving habits of the driver. That's starting to become common in large commercial trucks, where the fleet managers have a strong financial incentive to improve the safety and fuel economy of their fleet. So it can tell which drivers are doing hard braking and hard acceleration, again, through the use of these sensors and remote communications. We're actually starting to see those capabilities come into consumer vehicles for specific purposes like insurance assessment programs, which are voluntary, at least for the time being, and also for drivers education and drivers coaching capabilities for new drivers that can monitor how they're driving. We think we're all familiar with things like LoJack, which is really a form of Internet of Things. It's connected intelligence that tells you that your car's, where's your car that's been stolen, and actually allows remote disabling of that. We also see more interesting examples, newer, like Volvo has been piloting this thing they call Roam Delivery. That integrates the car with e-commerce systems so that the car owner can place an order online at an e-commerce site like they usually do. When it gets time to decide and tell the system how you want it delivered, one of the options is to say, well, I'm going to be at work from such and such hours, or I'm going to be at a shopping mall for such and such an hours. Please deliver it to my car. And then a one-time digital key that can only be used once is sent to the delivery truck driver's phone, and they can go to that vehicle and actually put the delivery right into the trunk of the car. And Volvo at least said this was an extremely popular service during that pilot, and I think they're taking a serious look at it. You could imagine extending something like that to the predictive maintenance that we just discussed, and getting repairs, at least those repairs that can be done in the field, could be done while you're off doing something else and your car's parked somewhere else. We see things like remote preheating or pre-cooling of a car, and vehicle-to-vehicle communications, which people have been talking about for a long time, is getting closer to becoming a reality. There's a company called Peloton that has a version for trucks that if you have two trucks with that technology, they can link to each other, and now they can the back truck can draft off the front truck at a very close distance safely. And they've been proving out through demonstrations that this is safe, and they're going to run trials soon. So the point is that there's lots of this different technology making its way into in this case, cars. But I want to point out it's a lot more than just the sensors and the connectivity involved in making this work. You think about the OnStar service that requires putting up a whole call center infrastructure and developing a set of partnerships worldwide for emergency repair or roadside service responders, and setting up service level agreements with them and so forth. And almost all of these examples also have substantial software components, not just the software on the product itself, but up in the cloud. And so we see that companies that get a head start in trying out these things and experimenting, there's a tremendous amount of trial and error and learning, and that's why we really encourage early and rapid experimentation in seeing what you can do with your products and learning before your competitors or some startup beats you to the punch. But of course, it's not just about what goes into the product, it's also about the factory that builds that product. And factories already have a really rich and deep heritage of building instrumentation and sensors into their production systems. But with the Internet of Things and the connectivity, it takes it to a whole new level. And that can include things like preventative maintenance and remote maintenance on factory lines where downtime can be really expensive. We're also seeing it being used in a big way for process improvements. So you think about adding all of those sensors, you create a tremendous amount of big data, and companies are taking a look at data about their machines, the settings on the machines, the conditions in the factory, and environmental conditions like humidity, and putting it all together to try to understand how all of those impact the quality, the yield, and other critical metrics. And we actually see some factories that are now taking that intelligence and using it to automatically adjust their machine settings based on, say, the current humidity or the other conditions. And as a result, they're getting much less variability and much more precision in their manufacturing. The next logical step for this might be to actually correlate field failures so that whenever a field failure happens, you can go back to that big data that you've collected through your Internet of Things and say, what were the settings and how can we improve reliability further? Another area in the factory where we see people using the Internet of Things is to make their production lines a lot more flexible. It's not something that immediately comes to mind, but some of the newer robotics and equipments, when you put all these sensors in them, it provides the ability to do instant calibration. And this enables much more software-based changeover of the capabilities of the line. So you can quickly switch to doing a new type of product, a broader range of operations on the same single line without sacrificing your production speed or your quality. So those are a couple of ways it's being used in production. What about logistics and moving those things? So here where we see things like a much more precise tracking of where that order or that shipment is. And this can be done through things like, of course, the GPS on the vehicle, but combining that also with external data, you can do things like understand what the current and projected port congestion is or what's the weather ahead, and put that all together to provide much more reliable estimated times of arrivals and alerts about potential late arrivals. So you get those alerts much earlier than you would with your conventional systems where you often don't know till after the thing has actually not showed up. And logistics providers who can add these types of capabilities into their vehicles and their systems, that can be a real differentiator for them. It can also provide, the Internet of Things in the logistics world, continuous monitoring of the condition of the goods in transit. This would be things like temperature, humidity, shock, and vibration. And it can be used potentially to try to correct a problem before it does damage. Like, say you have a malfunctioning refrigeration unit on a truck. You could get that fixed. These types of sensors can also be used to unambiguously assign liability for damaged goods that have either been dropped or damaged in other ways due to negligence. And finally, of course, a huge area of opportunity is in service. Now, we've talked about a few of these already when we talked about the product, the predictive maintenance and the condition-based maintenance. And one of the things I want to point out is this allows you to do maintenance based on actual operating conditions of the vehicle and its current things that it's telling you, like, I'm seeing too much vibration and temperature here, rather than the traditional way which says after 100,000 miles you should do X, right? And if everybody's doing the same thing at the same time, you're actually doing that maintenance too early for a whole bunch of people, so they're paying for stuff that they don't need yet. And then there's a whole bunch of other people who that's actually too late, so that the car actually broke down because they didn't get it fixed on time. So this type of predictive maintenance that Internet of Things enables can really help. Another part of service is remote configuration and update. So this is things like uploading software to fix the problem, which is way less expensive than sending a technician out to fix the problem. But also we see innovative uses like using the software instead of building multiple models that have different capabilities, you build one model that's sort of has all those capabilities, and you use software to configure what capabilities you turn on for the customer. If you think about it, this makes upgrade just a remote software switch that happens instead of having to deliver a whole new vehicle or system to the customer. The last thing I want to say about service is that we talked about some value-added services. So this goes beyond just service and repair as service to value-added services like let me help you improve your safety or your fuel economy. And along this line, we see something called outcome-based models or product as a service. I'll talk about that more in a minute, but essentially it's people buying the outcome that they want rather than buying the product itself. And what we see is that this area, this last area of value-added services and new business models layered on top and enabled by the Internet of Things, that really holds the potential to go beyond modest incremental improvements and to let manufacturers and service providers really reinvent themselves and take real quantum leaps into new markets and new types of services. So I'm going to give a couple examples that might give you some ideas of what we're talking about here. The first one is a company called Fleet Advantage, and they're a truck leasing company. So they're at their core, they're just a financial services company, right? We'll help you finance your fleet. But they actually kind of turned that model on its head in a couple ways. So the first one was a realization by them that the traditional model within this market is a 6 to 8 year lease, which was fine 50 years ago when truck technology didn't change that fast. But these days, after 6 to 8 years, the fleet owner has missed out on a couple generations of improvements in fleet safety and fuel economy and other new technology. And so the first thing they did was they said, we're going to make our lease terms 2 to 3 years so that you're continually able to get the latest and greatest technology, you, our customer. But the other big part of what they did is the Internet of Things part, which is they said, these modern trucks are generating a tremendous amount of data that most people are not taking advantage of. So they were able to tap into that data and bring it all together in a normalized way in a dashboard, a simple, easy-to-use dashboard that was laid out, because these folks, they're actually trucking industry folks. So they understand how the mindset of that industry. So they were able to put it together in a way that makes sense for fleet owners. But I think the genius was beyond that. They actually spent a fair amount developing intellectual property to normalize the truck's performance. So what does that mean? It means they could accommodate or account for differences in terrain and the weight of the load and weather and other conditions and compare the performance of trucks, benchmark the performance of the entire fleet, and find out which trucks are performing better and are outliers on the good side and the bad side. And on the good side, they could go and find out what those truck drivers are doing and maybe try to emulate that across the rest of the fleet. And for those that are underperforming, it could be the driver needs some additional training, or it could be an equipment problem. And they actually have a bunch of domain experts, industry veterans who help their customers to figure out what those issues are and resolve them, and we'll even go on site to help figure that out. So I bring this all together to say that here's someone who took a business, which is just financing, and turned it into much, much more than that, using the Internet of Things embedded into these products. And as a result of that, as you can imagine, they're able to charge for these services and have much better margins than their competitors have. Now, another example, you may have heard of this company, Big Belly. They noticed, the owner of this, or the starter of this, noticed that in most municipalities with the public trash cans, they fill up really fast with highly compressible trash, like styrofoam cups and paper. And so he said, boy, if you had a trash compactor here, you'd have to only empty these like a fifth as often. You'd save a lot of money in these trucks driving around, which also tie up the city streets, by the way, if you ever stuck behind a garbage truck. And so what they said is, well, for trash compactor you need power, so let's put solar panels on there, and voila, they had the solar-powered trash compactor. that became popular, but they noticed they couldn't get the full value because they were being emptied on average when they were only 60% full. And the reason, if you think about it, the Department of Public Works does not know how full these things are, and they don't want to take any chances that they're going to be completely full, because what do you do if you got trash and the trash compactor's full? Is, well, a lot of people will just throw it on the ground. And they didn't want that happening in their cities. So they thought about it, and they said, it would be pretty easy just to put a sensor. We've already got that plunger that compresses it, and just read when it's getting full or nearly full, and then add a cellular module to it that tells the city workers, hey, it's time to empty these. And so that's what they did, and that worked great. And there's a couple things I want to point out about it. One is they didn't set out to say, hey, we want to be an Internet of Things company. What they had is they had a specific problem, and the Internet of Things was the solution to that problem that they had. So that's really the way to think about this, is not how can we be Internet of Things ourselves, is just to think about the problems you have and which ones the Internet of Things can solve. The other thing I would point out is that this became, they noticed that their customers, the people in the City Hall, besides the Department of Public Works, started coming to them and saying, you know, we've been thinking about putting Wi-Fi hotspots around the city. You've already got power and a cellular connection back to the Internet. Can we just add this and have Wi-Fi hotspots in our parks and city benches? And another one wanted to do something similar with smart lighting and using this communication channel for that, and another one with environmental sensing. So they actually discovered they had created a platform unintentionally that was a lot more than just a smart trash can. So another thing to look for is, as you create these, is there may be opportunities for you to become a platform for a broader set of problems than the initial problem. So I talked about outcome economy and selling outcomes. Basically that means this has been an evolution in manufacturing from selling things to selling services for those things to saying, hey, don't bother buying the thing, we'll just sell you the outcome. The prototypical example being jet engines. It's called Power by the Hour, and all three of the big manufacturers, which includes Pratt & Whitney and GE and Rolls-Royce, all three of them will offer that instead of buying the engine, so some of the engines you see on these airlines are actually not owned by the airlines. They're owned by the engine manufacturer, who has responsibility for repairing and keeping that engine running. They have uptime requirements and service level agreements, and then that relieves the airline of all that responsibility, and they just pay by the hour for that. A couple other examples just to shed some light, pun intended there. Philips, you can buy by the lumen instead of buying lights, and they'll make sure and replace those lights before they burn out. Make sure you always have lights. Schaeffler Industries will sell you their service of their bearings for big wind turbines instead of buying that. Again, they're using Internet of Things with lots of sensors so that they can know when these things are starting to go wonky and make sure they service them properly. And you pay by the rotation instead of actually buying them. A carpet example, which is a great example because now this service, the carpet company owns the carpet. They'll come in and clean that carpet as part of the service, and if they see any square that's worn out, they just replace it. So your carpet looks perpetually new, and you never again have to rip up your whole office to replace the carpet. And Atlas Copco, which will sell you, instead of buying an air compressor, you can buy compressed air by the cubic foot and at a specified pounds per square inch, and humidity and purity and so forth. So, and there are many more examples. This is just to show you that a lot of companies are doing this, and it's being enabled by the Internet of Things in many cases, because the Internet of Things is what enables predictive maintenance, remote maintenance, and those kinds of things which are critical to keep these machines running in this new model. With this new model, by the way, a lot of things changed. Instead of all the cash up front, it's spread out as an expense over time. The interests of the manufacturer become to make this machine never fail. They don't make money when it needs service. They lose money. It protects the company against the customer against obsolescence. Of course, it's new pricing models are required. one thing that a lot of providers discover is that they become much more deeply embedded with their customer, and they have conversations about the outcomes and how to optimize those outcomes. They become a much more strategic partner, and the result can charge higher margins. I want to close my section off by talking about just democratization of the Internet of Things. And if you go back 20 years ago, say to the mid-90s, then you would see there were people doing the Internet of Things, but only the richest of companies with the most absolute high-value use cases that could justify very expensive implementations. That's been changing in a huge way, especially in the last few years here. The long-term trend here, this is a view of hardware that we're seeing here. Keep in mind this is a logarithmic scale on the left, $100,000 at the top and a penny at the bottom. And all of the devices, the sensors, the microprocessors, the GPS units, the communications devices, they've all have this downward curve, 10x every decade or so. And that has helped bring this within reach. But the bigger piece, I think, is the implementation piece. And so what do I mean by that? So if we look at what it takes to pull this off, that hardware that we were just looking at in the previous part of the screen is just the beginning, right? You need local communications, device management, gateways, you need middleware and a wide area, development platforms, and storage, because this data is much bigger but also much different than traditional data. And the analytics, a whole new set of analytics and types of analytics. That this is different, again, than traditional analytics. Security is something people are just beginning to realize how important it is. And of course, then on top of all of that, you've got to build your application. So in the old days, and by the way, what you're looking at here is ChainLink's framework for looking at this new world of IoT platforms. There are platforms around all of these things, and some platforms combine many of these pieces into one platform. So what that has done is, in the old days, you would have to build all this yourself. It's insanely cost prohibitive for most applications. Now it's just become easier and easier to pull all the pieces together into one thing, and has brought Internet of Things within reach of many, many more companies and many, many more applications. And that's one of the reasons we're seeing this explosion of interest. And I think with that, I'm going to hand it off to Howard to talk about some more things. So Howard, you go ahead, and I'm going to give you control as you're talking.
Okay, great, Bill. Thank you, and thank you to everyone who's participating in the webcast today and giving us a little bit of your time. First of all, just for those of you who may not be familiar with PTC, by generic standards, I guess you'd call us a mid-sized company, but when you look through the lens of the discrete manufacturing space, we would be considered a large company, as that's sort of the exclusive source of the revenue of our company that's been around for 20 years. We have, for the last 10 years or so, sort of positioned the company around the fact that we help manufacturers create and service products. And then several years back, we started to recognize that our own customers were beginning to connect those products, and if they connected products to the internet, they would design them differently, they would service them differently. And so we went off and acquired two of the leading IoT platforms in the market, and most recently acquired a big data analytics company. So that's sort of how we found ourselves into this IoT space. What I'd like to share with you today, as Ann had mentioned in the overview, are really a discussion around 4 topics. Given the very dedicated focus we have in manufacturing, I'd like to share our perspective on what we think IoT means for manufacturers, both the thing makers, the product OEMs, and their manufacturing and supply chain processes. I'll talk a little bit about how connectivity, building upon what Bill just said, is becoming ubiquitous throughout the value chain. Then switch a little bit to the types of new applications that manufacturers might turn to enable transformation within their enterprise. And then, as Ann had indicated at the beginning, I'd like to kind of wrap it up with giving you a sense for how tangible all of this is. When you have this conversation. It seems like it's a very big topic, and many folks probably say this all sounds great, but how on earth do I ever get going? And I'd like to wrap this up with sort of a perspective that you can actually move very quickly in this area. So I think I'd start with a view that we have at PTC that sort of says the traditional worlds of digital and physical are separate worlds. We have lots of business systems spread across our enterprise, from design systems, PLM systems that help us capture digital information about our products, to customer management systems that keep track of the customers that buy them and how they use them, to ERP, supply chain, MES, and so on and so forth. But generally speaking, that information is input through the form of people interacting with business systems as they're interacting in a somewhat disconnected fashion with the physical world, whether that be products, materials, or devices or assets. And what we think at PTC is that the worlds of digital and physical are rapidly colliding as a result of the Internet of Things, and that companies need to start viewing this world as, yes, somewhat distinct, but really inseparable from a business process automation perspective. And the thing that is unique about the new world of IoT and manufacturing is that these physical things now have a voice, and that can be anything from an individual sensor to a large piece of manufacturing equipment to the products that we ultimately send out and put in the hands of the customers. But they all have a voice, and that voice can become really a first-class contributor in the automation of business processes. So let's look at that a little bit more. When we talk about things, most of the companies that are on the webcast today, or many of you, represent what we would call the thing makers. You're really the organizations that are powering the Internet of Things, because whether it be sensors or new products, the expectation or forecasts are that the several billion devices that are connected today within several years are going to quickly expand to 50 billion devices, and then within the next, let's say, 15 to 20 years, to 1 trillion devices that are connected to the Internet. And these are going to be the products that manufacturers create and the sensors and equipment that they use in their factories and in their supply chains to enhance their systems and their business processes. The concept is that connectivity in itself isn't really all that useful. We need a way to turn connectivity into business value. And that really comes in the form of applications, and applications that leverage the explosion of sensors in the factory and in the supply chain, and the new generation of products that we'll make and the equipment that we'll buy, to integrate that with external data sources, from existing business systems or third-party data sources, to create new business applications that generate value in the Internet of Things. And we expect that that'll be somewhere by 2020 around 5 million applications that are developed. And as we approach this 15 to 20 year outlook, it'll be more like 500 million applications. So how is the world going to realize all these new applications and capture this business value, and how specifically will a manufacturer who has sort of endless opportunities be able to keep pace with the Internet of Things and the application development opportunities that exist? If we look a little bit deeper, again, keeping in mind that when we talk about connectivity, the expectation is that, and as Bill said earlier, all the trends are headed in the right direction. It's becoming cheaper, it's becoming more standard, to make these connections, but that connectivity isn't just about the equipment and the sensors. It's also about connecting the people in the process, the business systems in the process, and external data sources. Bill mentioned temperature and humidity, for example. And if we look at a manufacturer in terms of how this connectivity can help across their value chain from a supplier perspective, and we have suppliers today who, as PTC or ThingWorx customers, are extending a value proposition to their customers to allow access and visibility to quality metrics or inventory levels or their own equipment that is being used in the factory, to be able to understand the status of that equipment and when that equipment might be in need of service. The factories themselves obviously operate with a lot of equipment. That equipment obviously feeds a higher level process view of how the factory is operating, and key performance indicators such as OEE or others. And more we're seeing that a lot of the tools in the factory, whether it be a torque wrench, is becoming connected so that somebody assembling the products knows exactly what level to torque a particular bolt or something to, and they have the ability to record that and measure that the product was actually assembled in accordance with compliance to quality. From a transportation perspective and logistics perspective, sensors are already, telematics and fleets are being enabled with sensors, and there will be many more that will come, letting us know everything from the location to the impact of environmental conditions to optimal routes and schedules and so on. And obviously with the customers, this translates into ensuring that we're keeping a schedule relative to the status of their deliveries, and also the quality of goods and services once delivered. So looking at sort of all of these components together, and the idea that we're talking about sensors, devices, business systems, people, and other data sources, the opportunity in IoT for manufacturing is really to capitalize on the new wave of real-time operational data from connected things, sensors and devices, in combination with the existing sources of sort of traditional data around factory automation, ERP, MES, and logistics, to enhance and transform the business processes. And I'll get into this in just a little more detail here in a second. So if we look at the left-hand side, and this really reflects the typical, at a very high level, the typical manufacturing environment today. We see everything from environmental factors, as Bill mentioned, to critical information from our suppliers, transportation and logistics, lots of sensors deployed in both of those environments. And then within the factory, there's control systems, PLCs, HMI and SCADA systems. There's MES and manufacturing operation management systems, and this idea of connected manufacturing intelligence, which really brings all of that data together. And then at each factory, there are also every day and more sensors being deployed, whether that's a sensor on a motor to check its vibration and temperature, or sensors deployed on the line to measure the process. All of this data combined, both internal and external, is what enables sort of this IoT transformation. And we would characterize that as the transformation opportunity is gaining unified process visibility and connectivity across people, systems, assets, and devices, and enabling comprehensive operational intelligence that spans everywhere from the supply network to the shop floor and up to the boardroom. The key here is that this is real-time information, brought on by real-time connectivity to the sensors and devices, as well as the business systems. It enables social so that people can collaborate. Mobile so that anybody has access to that data sort of regardless of where they're at. It's mashable in the sense that you can combine many different data sources to power new applications. And of course, in this environment, as Bill described, there is a tremendous amount of data flowing back and forth. So there's a big data analytics opportunity here to make sense of and identify certain patterns and business opportunities, particularly in the area of prediction. Finally, for manufacturers to kind of take advantage of this IoT transformation, one of the core elements that they'll need is to be able to develop applications very quickly and continuously evolve those applications. I think manufacturing is a very interesting space when you look at this opportunity, because the idea that there are going to be new applications that bring the physical and digital world together, and that is going to be somewhat tailored to every manufacturer's particular environment, meaning the makeup of their factories and their supply chain and whatnot, really makes the case for a rapid application development and ability to continuously innovate on that environment, something that is, very, I think, very appealing. So if we look at sort of the data set, the opportunities, what we see is companies building, real-time dashboards that integrate this information. It may be for a particular line or for a factory or even across multiple factories in the enterprise. We see companies building applications in the area of asset and material tracking in the supply chain. So understanding the inbound and outbound status of logistics. And then for equipment in the factory, this is sort of an interesting idea. It's more than an idea. It's new technology where somebody could look at walk through a factory and, with new technologies like augmented reality, blending information coming off the devices with back-end systems information, have an instant and up-to-date view of every asset in the factory. So here what you see, this is a generator actually outside of our building here, but if you imagine it to be a piece of equipment in the factory, you see that there's a preventative maintenance alert flashing to replace the oil filter. There's a real-time alert here that suggests that perhaps one of the motor cushions has broken apart and fallen down, and there's some big data analytics suggesting that there's a 75% chance the motor shaft is going to fail in the next several weeks, and then some information about the status of that particular equipment, its model number, maybe the last time it was maintained, who the maintenance provider or service provider is, etc. But IoT enables really any type of these applications to be delivered, whether they're process-oriented, logistics-oriented, or equipment-oriented from a service and maintenance point of view. Okay, so that all sounds great, but how does it happen? And this is where I think an purpose-built IoT platform is key. So I would say, generically speaking, if someone were to start out today building a platform, a software development platform or app development platform for the Internet of Things, one of the things that you'd have to focus on is connectivity, and as Bill suggested in his presentation, you'd have to support, a lot of variability in that space, hybrid networks, heterogeneous device types communicating in different ways. You'd have to be device and communications agnostic. On top of that connectivity layer, you'd want to have a good application enablement and rapid app development environment that allowed you to integrate third-party data sources and business systems that allowed you to store and correlate data, unstructured data from people, structured data from business systems, and time series data that's coming off of the connected devices, equipment, and sensors. You would want to have some standard IoT capabilities that allowed you to create and monitor alerts in the process or on the equipment, to remotely access and control those devices, to be able to deploy software out to a device if that's what's required to either fix it or further perform further diagnostics. You'd want to create business process flows that respond to certain events and orchestrate the communication of the process across different business systems, perhaps both internal and external to the operations. And you'd need a integration hub that enables you to combine the physical data with the digital data that exists in existing systems today as really the way to enable the combined new world of physical and digital together and transform business processes. So if I look into this in a little more detail, without going into the specifics of what we offer here at PTC, but suffice it to say, one of the acquisitions we made of this technology called ThingWorx, has an architecture that is very similar to what I just described. And the proposition that is put forward is that with an IoT, purpose-built IoT platform like this, that companies can create this new generation of IoT applications, 10 times faster. And not just create them, but this isn't the old world where we write a bunch of software code and then it's sort of brittle. In this new world, we create applications and we iterate, very quickly on furthering those applications to, fine-tune them to business value. So in light of that, I wanted to present an example. I can't show the actual demonstration here. It doesn't work that well over the webcast. But if you look at this particular example, it started with sort of the blank template in the ThingWorx Composer. And there's really two key pieces here. A Composer, which is an end-to-end developer environment that allows you to quickly create templates and then add properties and information to those templates about the things or the process. And then the second is a codeless mashup builder that's really intended to empower business users, not developers, to configure applications that are of interest to them. So we have a demonstration on the website that shows how somebody started from sort of ground zero and built an entire application in the course of roughly an hour, just under an hour. I would encourage people to take a look at that. If this is, if it sounds too good to be true, then go to this URL here, ptc.com, go ThingWorx demo. It's called the ThingWorx Platform Fleet Logistics Synopsis Demo Video, and I think you'll get a great sense for how IoT platforms can enable the rapid creation of sort of endless applications that can bring these digital and physical worlds together to create and enable process transformation. To kind of wrap up from a PTC perspective here, the typical way that we have seen success engaging our customers, first of all, we have this idea of an IoT value roadmap, which really spells out the use cases related to driving top-line revenue or bottom-line efficiencies, and then how those use cases course their way across the functions of an organization, including manufacturing and supply chain, but also engineering and service, as well as the use cases that enable the kind of customer transformation that Bill was discussing. And typically we hold a half-day or day-long workshop as a way to bring forward the use cases, the many use cases that we have from the customers that have deployed IoT into a workshop to sort of encourage and inspire what can be done with IoT, and then from that, prioritize sort of the opportunities and choose a couple to get started with. And then these are very rapid kinds of engagements where we can build out an application that includes connectivity to some devices and systems, and quickly demonstrate how these new apps can be built in a very short period of time. Alternatively, we have a developer program that is launching in August, mid-August here, so a couple of weeks, where developers can get their hands on this technology themselves and sort of prove it out on behalf of the organization. So with that, I'd like to thank you again, and Bill, that kind of concludes what I had prepared here. I'll turn it back over to you.
Okay, this is Ann. So now I just want to remind you, if you have questions, you can type them into the chat question box, and then we'll begin the Q&A session. We already have a bunch of great questions queued up. So the first question is, we already have much of the manufacturing software you showed, but none of it is connected to the cloud. How do we keep what we have but also expand to Internet of Things? And I suppose that question would be for Howard.
Yeah, thanks, and Bill, you can add to it as well. But that's a great question, and it sort of underscores part of the argument I was trying to put forward, which is a lot of this data exists today. The technology can be deployed in a cloud, either in a commercial cloud or a private cloud. Most of our customers, within their factories have an intranet cloud that they want to deploy the software in. But it then really allows you to, broker information. A lot of the new applications today, if you take a product, for example, the product has embedded software in it. And some of that software needs to be on the product or at the edge because of response times and maybe concerns for security or whatever it might be. A lot of the other software that it's going to interact with to enable new applications would be in the cloud. And in fact, the business applications themselves are generally going to be written against a cloud collection of the physical and digital information. So that's exactly what an IoT platform can enable, is the ability to connect the existing business systems you have with new data streams coming off of connected devices and individual sensors into a cloud that can support new applications, mobile, etc., social being written against it in a cloud environment.
Great. That sort of fits in with this next question, which is, I guess, either for Bill or Howard. Do we create a platform and bring our third-party partners in, or is this environment geared towards using a third-party software provider to manage the information and our trading partners together?
Bill, do you want to take a stab at what you've seen there, and then I'm happy to add some.
Sure. I think there's kind of two sides to the question. One is, for sure, you want to use a third party, sort of tying into the previous question. These platforms have a cloud infrastructure that's already built, and they've got tools for integrating your applications and so forth. So you'd be crazy not to take advantage of one of those. And I also want to point out, to add on to the last one, that PTC has kind of taken that concept one step further, in particular for manufacturers, because a lot of the things that manufacturers want to do with their products are very similar. So they have this thing called Converge, in which they've kind of pre-assembled a lot of the the remote diagnostics and dashboards and stuff like that, that make it even easier. But I think the question also, if I understood it correctly, is saying that we may need to assemble connectivity to partners in a sort of an ecosystem together, and should we rely on a third party that's already done that, or are there? And I think the answer is it depends. There may be cases, especially in the case of logistics, for example. If you're in logistics, there are some platforms out there that have assembled and pre-connected a lot of the partners, and it might make a lot of sense. On the other hand, if you're building something like, say, a roadside assistance, that's probably your baby, and you're going to be on the hook for actually hooking up all the pieces and getting the service providers hooked up to it. So, you know, it's kind of an ambiguous answer, but I think on a case-by-case basis, you would make that decision.
Okay. We have a couple of questions about standards, so let me read one and then append it with another variant on the question. So, with emerging technology and standards, how do manufacturers avoid the pitfalls of technology redundancy in the next 1 to 2 year horizon? And then there was another question that says, in essence, a lot of the hardware providers, the equipment providers, their Internet of Technology connects to their corporate systems, and they all rely on their own standards. So how do I get these disparate hardware systems to be able to talk together? So in other words, if is the industry converging on a set of standards, and will we be able to have shareable libraries or information, or is everybody going to be off doing their own thing, which in essence a lot of companies are doing today?
So that's an issue we've actually looked at a bunch, and I'll let Howard jump in if you want to. So it's true that the Internet of Things standards are evolving, as you know all standards are, but we're kind of in early stages. And so, but there are, you know, the good news is the standards are being put together. But that's exactly the role of a lot of these platforms, especially like device management platforms, is to insulate you from what's going on at the lower levels and abstract out what those devices are, so that and that's important, by the way, for legacy, to integrate a variety of legacy devices, so that those layers, if you use those types of systems, then even if as the standards change or things change underneath, you won't have to change your software. That's actually one of the big advantages of some of these systems. I don't know if you've got anything to add to that, Howard.
Yeah, I think you know, first of all, there is a lot of standards work going on, and the joke is always we have no shortage of standards. There's 100 and some odd very important ones in the world of IoT today. But the reality is, they are fairly new, and we sit obviously on like the Industrial Internet Consortium and those bodies that are sort of key in developing and guiding these standards. But some of them in the factory area, really, what IoT is doing is bringing some, even fairly mature standards to, the current infrastructure and landscape. So, modern web standards that allow you to expose information in a way that it can be consumed. And then I think, one of the things that good IoT platforms will do is recognize that there are, old standards that need to be accommodated to make good use of the information and enable these new apps. So that's something that we focus a lot on as well, which is embracing, sort of the old to the new world. But I think everybody is eager to see a new set of standards. It helps us as developers, and it certainly helps the customers when these new standards emerge that are, sort of purposeful for this particular area. But I think we have, a couple of years for that work to really start to make a big impact.
Right. So we still have a whole bunch of questions, and I know it's 2, so I just want to squeeze in one more. And I want to say to the other folks who have asked questions, we will follow up with you directly, either us or when the questions are directed towards PTC, I will have them answer you directly. I think this one's a really important one too. How critical will the professional services role be to integrate objects to enable customers to benefit from the entire value chain that IoT offers? And how available do you see these skill sets today?
So
yeah, Bill, let me take
it.
Go ahead.
Yeah, you go first. You go first.
Yeah, I mean, I think that's kind of a wide open question. We see, a lot of companies just sort of entering IoT. Probably some of the help that they need is really around setting the strategy and looking at what the process automation opportunities are and the applications that will be built. And then, to some degree, there is going to be a data integration issue. The technology, I think modern technology makes that much easier. So I think those kinds of services, there are many partners that we work with, systems integrators, et cetera, who recognize this opportunity and are building out sort of a full spectrum of those types of resources. I should mention, in light of the comment you made, Bill, earlier about the question related to the ecosystem, I think most modern IoT platforms will also recognize that this isn't a one-vendor kind of approach to solving the problem. So, for example, we have a marketplace, and that marketplace is populated with all kinds of connectivity components, from a Twilio extension that allows you to send text messaging to somebody, to hardware that's enabled, up to perhaps a very specific vertical application that solves the problem. So I think some of these services may come in different forms and forms of extension and value in places like the marketplace. I think the one challenge area where resources are definitely tight in IoT is around big data analytics. Perhaps one of the most sought after and yet scarce resources today is data scientists. And there I think it's important to look at at complementary techniques such as machine learning, et cetera, where you can relieve some of the burden from difficult to find and keep scarce resources in the form of data scientists with more technology-driven, modeling of big data analytics kinds of opportunities.
Okay, so we're in the overtime box now. So firstly, I'd like to thank our speakers today, and in particular Howard, for helping to make this important webinar happen. And I'd also like to thank our attendees for hanging in here. I know it's a lot to talk about, and we've only scratched the surface. Just to remind you, you will be receiving a recording of this webinar. Also, you see on the screen emails of Bill and Howard, as well as other resources that you can connect to get more information. If you're interested, I really encourage you to see the demo that Howard talked about. I actually was at LiveWorks and saw the composition, if you will, of new applications, and I was extraordinarily impressed with the ease that you could actually make something happen. Finally, if you have further questions, please don't hesitate to reach out to us, and we'll make sure that your questions get answered by us or PTC or both of us. And for some of you who put questions forward for this webinar, we will make sure that all your questions are fully answered after this. We just couldn't get to all the questions today. Again, thank you so much for attending today, and I wish you all a great afternoon. Thank you.
Thank you.